Dear students, this is video part 2 in the series of real numbers for class 10. So let us start. So real numbers, before proceeding, we should know few terms. Lemma. Lemma is a proven statement used to prove other statement. Or we can say it is a proven statement that can be used for solving larger problem. Initially, lemma and theorem are considered same. Okay. Algorithm. It is a series of well-defined steps which gives a procedure for solving a type of problem or task. So well-defined steps which are used to solve a larger problem. This is known as algorithm. Now, the division algorithm. For given integers a and b, where b equal not 0, there exist unique integers q and r such that a equal to bq plus r, where r is greater than equal to 0 but less than modulus b. Now, we have to concentrate to this point, Euclid's division lemma. For a pair of given positive integers a and b, there exist unique integers q and r such that a equal to bq plus r, where r is greater than equal to 0 but less than b. So we can say for any pair of two positive integers a and b, there exist unique integers q and r such that a equal to bq plus r, where r is greater than equal to 0 but less than b. The integers q is the quotient and the integer r is the remainder. The quotient and the remainder are unique for given pairs of a and b. So this is very important. The remainder r is always greater than or equal to 0 but less than the divisor b. From this we can get some more facts, important conclusions. So simply it is asked again and again in the exam also. Any number can be written in the form of 2q or 2q plus 1. How can we prove that? If a is any integer and b equal to 2, then there exist integers q and r such that a equal to 2q plus r, where r is greater than equal to 0 but less than 2. So we can say if r is 0, then a equal to 2q. If r is 1, then a equal to 2q plus 1. So, but r cannot be 2. It is less than 2 and it is integer. So we can get only two values, 2q and 2q plus 1. So any integer can be written in the form 2q and 2q plus 1. If a equal to 2q, then a is an even integer. If a is 2q plus 1, then a is an odd integer. Hence, we can say every integer a is of the form 2q or 2q plus 1, where q is some integer. So you can think any integer. For example, you can think 50. It can be written as 2 into 25, where q is 25. You can think 51. So it can be 2q plus 1, 2 into 25 plus 1. So in this way, we can write any integer in the form 2q or 2q plus 1. Now, next, let a be any positive integers and b equal to 3. B equal to 3, then by Euclid's division lemma, there exist integers q and r such that a equal to 2q plus r, where r is less than 3 but greater than equal to 0. So a can be written as a equal to 3q when r is 0, a equal to 3q plus 1 when r is 1, a equal to 3q plus 2 when r is 2. So a can be 3q, 3q plus 1 or 3q plus 2. And 3q plus 2 again, 3q plus 2 can be written as 3q plus 3 minus 1 because 3 minus 1 is 2, and we can get the common 3q plus 1 because q is constant, so q plus 1 is also constant. So we can say here 3q prime minus 1. So this is also constant, so this can be written as 3q minus 1. So 3q plus 2 can be written as 3q minus 1. So now conclusion. Every positive integer a is the form of 3q, 3q plus 1 or 3q plus 2, or sometimes you can say 3q minus 1. But we have to remember this only. Every positive integer a is of the form 3q, 3q plus 1, 3q plus 2. Think any integer. You can write it in the form of 3q or 3q plus 1 or 3q plus 2. Okay. Now, let a be any positive integer and b is equal to 4. Then there exist unique integers q and r such that A equal to 4q plus R, where R is greater than or equal to 0, R is less than 4. So R can be 1, 2, 3. So A can be written as 4q, 4q plus 1, 4q plus 2, or 4q plus 3. If A equal to 4q and 4q plus 2, then A is an positive, A is an even integer. If A equal to 4q plus 1 or 4q plus 3, then A is an odd integer. So we can say every integer A is of the form 4q, 4q plus 2q. So every even integer is of the form 4q, 4q plus 2q, and every odd integer A is of the form of 4q plus 1 or 4q plus 3, where q is some integer. So we have discussed basics about this. We will discuss more in the next video. Thank you. Thank you very much.